This mini lecture is about displacement and average velocity using notation consistent with the book. So let's say that we have a situation where we have a particle that's moving as I'm about to describe in this table. So let's say at position 0 the particle is at time 0 the particle is at position 0. So let me come over here and draw a coordinate axis. Just one direction is fine. And so here is position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then at time 1, the particle is at position 2. And at time 2, it is at position 5. And at time 3, it's at position 1. And at time 4, it's at position 0. And so we can represent this with little displacement vectors. As I will do right now, I'll use little red vectors. And so I start at position 0, and during time 1 I move from here to here. That's t equals 1 second. And then during the second I move from 2 to 5. T is equal to 2 seconds. And then during time the second 3, I move from 5 to 1. So I'll displace it downwards here. That's t equals 3 seconds. And then finally, in second 4, I move from 1 to 0. Like this. T is equal to 4 seconds. So these two representations are equivalent. Here's the tabular display, and here is this is what's called a motion diagram here. That's actually something we'll be doing a fair amount of, so I'll write that down. Motion diagram. And then another way of representing this same situation is with a graph, and so let's do that over here. I'm going to make my x be vertical, like this. This is the vertical is x in meters, and that's going to be 1, 2, 3, 4, 5. And then the horizontal axis is time in seconds. 1, 2, 3, 4. 1, 2, 3, 4, 5. And so if I look at the tabular data, let's represent the tabular data over here. And so at time 0, I'm at position 0. And at time 1, I'm at position 2. And at time 2, I'm at position 5. And at time 3, I'm at position 1. And at time 4, I'm back at position 0. And so if I connect the dots here, I have a representation of the tabular data as a graph. So we have 3 representations. Okay, so now we're ready to talk about average velocity. So average velocity, v av x, because we're doing this along an x-axis here, so I should have labeled this as an x-axis, is going to depend upon the time interval that we have. And so I'm going to say that if we go from 0 seconds to 1 second, that's defined to be the position at 1 second minus the position at 0 seconds divided by 1 second minus 0 seconds. So in other words, that is the displacement from 0 to 1 second divided by the change in time. And so from the table here, that's going to be x of 1 is 2, going back to this formula, minus position x of 0 at time 0 is 0 meters, and then the time elapsed here is 1 second. And so the average velocity in the x direction over the time interval 0 to 1 is 2 meters per second. So if I was to, for example, calculate the average velocity over the time interval from 0 to 2 seconds, that would be 0, 2. It's going to be the position at 2 seconds minus the position at 0 seconds over the time interval, which is 2 seconds minus 0 seconds, which is again the displacement between 0 and 2 over the corresponding change in time, and that is going to be equal to 5 meters, looking at the table here, minus 0 meters over the elapsed time, which is 2 seconds, and that will be 5 over 2, which is 2.5 meters per second. And so looking at the data here, we have over the time interval from 0 to 1, we have a 2 meter per second average velocity, and over the time interval from 0 to 2, we have a time interval, an average velocity of 2.5 meters per second, slightly greater. Okay, so let's do another one. Let's go the average velocity in the x direction from 2 to 3. And that's going to be equal to the displacement from 3 seconds to 2 seconds, represented by that, divided by the time interval, 3 seconds minus 2 seconds, which is going to be delta x 2, 3 over delta t, and that's going to be equal to 1 meter minus 5 meters over 1 second, which is minus 4 meters per second. Okay, so this is negative because the displacement from 2 to 3 is backwards. It's to the left, I should say. It's in the negative direction. You can actually see it right here. Here's the 1 second interval that we have, the 3rd second, and you can actually see the average velocity is very directly as this vector, which is minus 4 divided by 1, which is what we've actually calculated here. So let me do one more slightly surprising one, and that is this last average velocity we calculate is going to be the average velocity in the x direction from 0 to 4 seconds, and that's going to be x of the position at 4 seconds minus the position at 0 seconds over 4 seconds minus 0 seconds, which is going to be equal to 0 meters minus 0 meters over 4 seconds, which is equal to 0 meters over 4 seconds, which is equal to 0 meters per second. So the average velocity over this full time interval is 0 because we came back to where we started. And so if you look at, let's look at this particular one, x of 4 seconds minus x of 0 seconds. That's a 4 and that's a 0. Let me do this in another color so I can emphasize something. Let's see, so I'll switch to maybe magenta here. So this numerator right here, x of 4 seconds minus x of 1 second, we can rewrite like this. We can write it as x of 4 minus x of 3 plus x of 3 minus x of 2 plus x of 2 minus x of 1 plus x of 1 minus x of 0. So convince yourself algebraically that this magenta algebraic term is the same as this blue one in the numerator. And it is because this and this cancel, this and this cancel, this and this cancel, and you're left with just this x4 minus this x0, which is what the blue denominator, the blue numerator is. And so the reason it's informative to write it this way is because if you look at this first term here, this is the displacement that you get in going from 3 to 4. And so that would be this right here. And the next term represents this displacement right here. And the next term represents this displacement, and the last term represents that displacement. And you can see very clearly that the sum of these 4 red vectors is 0, and that's what this is telling us. So that's the average velocity. And I think I'll break this up into 2 lectures, and so we'll finish off with the discussion for the instantaneous velocity in the next lecture. We'll just use this as a background.